Hello everyone, I'm Yuanchun from Tsinghua University. Today I'm glad to introduce our work, ProxiMic, convenient voice activation via close-to-mic speech detected by a single microphone. As we all know, voice interaction is convenient, efficient, and intuitive. But voice input still faces some challenges. First, the voice wake-up process can be lengthy. Second, such interaction can be tedious and annoying, especially doing multiple rounds of voice input. Third, user risks exposing their privacy as their voices may be overheard or eavesdropped by a third party. Therefore, we propose ProxiMic, a close-to-mic speech sensing technique for handheld and wearable devices. With ProxiMic, user can keep the device close to the mouth and speaks directly to the device without wake-up phrases or button presses. In addition, user can also whisper, directly interrupt, and realize multiple rounds of dialogue. In recent years, several works have been done to improve the voice activation process. They use a variety of sensors and device-related gestures to shorten the wake-up time for specific devices. The difference is that we only use one microphone. To implement a close-to-mic speech detector, we first conduct a pilot study to find what feature can we use. We found the most significant feature is pop noise caused by air being blown onto the microphone while speaking. This is an example.
Nice to meet you. Nice to meet you. Nice to meet you.
First, in the time domain, the impact of the airflow on the microphone brings high amplitude, so the amplitude of close-to-mic speech with pop noise is usually higher than the background noise. Second, in the frequency domain, the pop noise area containing low frequencies is visible. So we adopt a two-stage approach to detect close-to-mic speech in time domain and frequency domain respectively. The first stage detector is based on the adaptive amplitude threshold with minimal calculation required. If the amplitude of audio signal exceeds the dynamic threshold, we will extract a 1-second audio clip and hand this raw signal input over a tiny spectrogram-based convolutional neural network for refined detection. We use smartphone to collect 3 audio datasets. They are voice commands datasets, background noise dataset, and 7 days daily records. We use recall rate and false accept per week per user as metrics to evaluate our model. The result shows that the most false accepts occurs when a person speaks from a distance and superimposes high-energy noise similar to pop noise. Recall rate is reduced in noisy environments such as subway. In Study 2, we conduct 4 analyses to understand the performance and boundaries of ProxiMic. First, in order to understand what CNN has learned, we calculated the silency map and occlusion sensitivity map of voice input. We found that our CNN model mainly responds to pop noise in the spectrogram. Second, we tested different form factors. The result shows that watches and phones have similar performance due to the similar structures. For headphones and recording pens, there was less obvious pop noise due to their outer shells, and the performance has been reduced. We also use a state-of-the-art ASR system to perform speech-to-text and calculate the word error rate of the voice command dataset. The result shows pop noise didn't significantly reduce the accuracy of speech recognition. For the privacy part, we invited 6 users, asked them to talk to ProxiMic and make sure the ASR recognition is correct. When one person speaks, others sit on chairs at different distance, eavesdrop carefully, and write down what they hear. We found that whispering can efficiently protect privacy. Finally, we compare ProxiMic to other traditional activation methods. Results show that our method was significantly faster than the traditional methods, and watches is faster than phones and headphones. For subjective feedback, our method have advantages in terms of speed and multi-round interaction. In summary, we present ProxiMic, a novel sensing technique that uses pop noise and close-to-mic feature to perform efficient, user-friendly, and practical voice input by a single microphone. With this, I would like to end my talk. Thank you to your attention. Happy to answer any questions.